V-weld calculation. Before we start the calculation, a lot of time this is confused with a flat belt. Now, if you look at this has a V groove. The serpentine belt in your car has a V groove. The purpose of that V groove or V slot is to ensure that this belt doesn't slide out in terms of when the tension gets loose or something like that. So these grooves basically helps this belt place into the pulley. Now when you look at these belts, they should be still you should be use the flat belt formula for solving the serpentine belt, or the belt looks like this. However, the V-weld formula that we're going to work on in this problem, which is the same formula, almost the same, just a tiny bit addition to this flat belt. So the mu beta, we have seen that before. The only addition is that divide by sine phi, which you did not have in the previous case. That phi is actually the V groove angle. So in the formula, the V groove angle is twice phi, 2 phi. So then if this V groove is say 60 degree, the V slot, you'll be using 30 degree in the formula. So look at however, first you have to know which one is a V weld, which formula to use. Now this one looks like the pulley looks like a gear. On the other hand, here pulley likes a simple pulley. So if the V shape is like this is a Harley-Davidson motorcycle. V-weld doesn't have to be Harley-Davidson, any motorcycle or other engines or anything that uses this kind of gear type of belt, and then you should be using that V-weld formula. Otherwise you'll be using the flat belt formula. So let's start with this problem. So for the same problem, previously we used 1,000 pound-inches of torque. In fact, by random situation, this motorcycle produces about same amount of torque. It's about 83,000 pound is equal to 83 pound foot, which is about the current engine produces a little bit more. Just for the sake of this example, by random chance, however, this pulley is actually 10 inches, but let's use 12-inch pulley so that we can compare this number with the previous problem. So in the previous problem, we use a 12-inch pulley, and let's say the tension, this side is the large tension, TL. This side is the small tension, TS. So if you take the moment, so we can do TL times the distance. So 12 is the pulley diameter. So from center O here to the tension, that is 6 inches. So 6 inches minus the small side tension, also 6 inches away from the middle, and this is equal to 1,000 pound-inches, which is about same as this motorcycle. So TL minus TS, we have found 6167 is my equation 1. And here in this tension formula, belt tension formula, TL TS times E power, let's say 0.2 is the friction coefficient, same as before. Let's say it is wrapping about 180 degree. This one is wrapping a little bit more than 180 degree, but let's use 180 degree, which is 1 pi 3.14 divide by sine 30. You have to be careful here. Whatever angle of that V groove is given, it should be half of that angle in this formula. So the TL is equal to actually 3.51 TS. That's what we have found. Now if you put this TL value 3.51 TS minus TS is equal to 167, so then I found TS is equal to 66 pound, and then you plug this number right here, that will give you the TL is 233 pound. If you compare this number with the flat belt calculation we did for the same amount of torque, for the flat belt calculation we found the small side tension was 190, while the large size tension was 357. So if you use a flat belt like this serpentine belt, even though it look like a V belt, but you should be using the flat belt formula. If you use this kind of belt to transfer the same amount of torque, 1000 pound-inches, you need way more tension than using these V weld.